A confirmation regarding the audio, please, guys. If you're able to hear me out perfectly well, kindly confirm the same. Thank you. So, hello, a very warm good evening to all of you, and welcome to Byju's Exam Prep IAS. Welcome to another session of geography, where today we shall be looking at the final portion in the area of climatology, in the unit of climatology, and that is the global climatic classification. Here, we get to understand what are the various different climatic types observed in different parts of the globe based upon the certain sets of classification which has been done. So that is something that we are going to refer to. Now here, this is the portion which is going to be relevant only for your prelims. This is something which is relevant for your prelims examination. Till now, UPSC has not asked this in the mains examination for general studies, and this has been a trend for the last around 10 to 15 years that UPSC has not been asking this in the general studies portion. UPSC does ask and mention about this, but in the optional portion of the mains exam. So ideally, when you prepare for this, only prepare it for the prelims purposes. Now here, what do you need to prepare for prelims purposes? You need to understand the properties of different climate types. Okay? What are the different properties of the various different climate types? That is something that we get to study here, and that is something which is going to be relevant for your exams as well. Now, if I have to point out which of the climate types are actually more important and which of the climate types are frequented in the previous year questions, you will find that you have equatorial climate, monsoon climate, then savanna climate, Mediterranean climate, and then we have British type of climate, and also you have the questions sometimes they can be asked from China type. So these are the major climatic areas and the climatic conditions that one needs to focus on when you are preparing for your prelims examination. Now, ideally, when you prepare for this, you should be aware that what are the conditions which are experienced in these areas or under these climatic types. What are the climatic conditions in terms of temperature variation, in terms of the rainfall that we receive, that during which season do we end up receiving rainfall, etc. That is something that we need to look into. We are going to take a look into the previous year questions as well, which will give you a further greater insight and a greater detail about how to shape your preparation according to the demand of the question here. Now, before we move into the particular portion of classification, first of all, I hope that we are aware about the difference between climate and weather. I hope that difference is something which is understood to us. If it is not, let me tell you, what do we mean when we say weather? What do we mean when we say climatic conditions? Now, both of them oftentimes are interchangeably used, and that is where both of them, many of the times, they are used in a way which is incorrect. So when we talk about weather conditions, so weather conditions, for example, today, you might experience cloudy condition, you might experience rainfall, you might experience sunny conditions where it is very hot and there is no cloud cover and you have the bright sunshine. So that is what can be categorized under weather conditions. So weather conditions are day-to-day occurrences in your atmospheric situation that we come across. For example, even though we know that the month of May and April is very, very hot, right? Across the country, generally, we have summer conditions during the month of April and May. But then, even in that case, sometimes you might have in the month of April the occurrence of rainfall, significant amount of rainfall. Now, that is referred to as the daily weather conditions. The daily temperature conditions that you come across in the newspapers, news headlines, etc. All of them, they represent the weather conditions. So, these are day-to-day atmospheric conditions. Experienced. Okay, the day-to-day atmospheric conditions which are experienced, that is weather. So obviously it can change from one day to the other. When we say climate, climate is an average of a weather condition experienced in an area taken over a time span of 3 to 4 decades. So for example, the month of April and May, regardless of whatever the day-to-day variations in atmospheric conditions might be, but we are aware that the month of April and May, that is going to be scorchingly hot. So it is a summer climate or a summer condition. So that is what is your climate. So it is the average of weather conditions taken over a 30-year time period. So that is where climate is something which is more static in a way, and weather is, if you can associate with it, dynamic. Suppose I decide today that I will, in the month of December, I will go to, let's say, Jammu Kashmir. Now there, what I expect the conditions to be? I expect the conditions to be cold, maybe snowy, maybe ice will be there, right? So that conclusion that I am taking before going to that place, that is based upon the climatic condition. Once I reach upon that area and once I reach to that place, it might be absolutely sunny, it might be raining, it might be snowing. So that is what is the daily weather conditions. So here we are going to look into the climatic classification across the globe. Now, when we talk about climatic classification overall, in the geographical world, this again has been a point of concern since time immemorial. Ever since mankind started exploring the world around him, at that point of time itself, they were curious that what are the weather conditions experienced. In fact, when you had the Greeks who were significantly important in deciding and also in deciphering, in a way, the map of the world, the cartographical map of the world, at that point of time, you had few of the explorers who were aware that if you go further north from the region of Greece, there are areas which are permanently frozen. If you go southwards towards the region of equator, the heat is almost intolerable. So the earliest form of climatic classification which was given in the terms of geography, the earliest forms of classification was very simple. You had the classification in a way where the polar areas, and then you had the temperate regions. Now, this was the early classification. Let's assume this being the equator. So the early classification that was given, as per that, you had the region around close to the region of equator that was always understood to be so very cold that it cannot support life. That was the understanding at that point of time. That look, around the region of equator, it is so very hot that no living being can exist there. Obviously, we know better because we know we live in that region itself. So this portion, that is what was referred to as the torrid zone. Then the present day tropical area, that was referred to as torrid zone as per the earlier classifications. Then you had the regions in the temperate region being temperate zone. This was at that point of time considered to be the ideal condition for survivability. Ideal conditions so that the temperatures, they don't go to the extremity and it is always moderate. So that is why temperate regions were always considered to be very ideal. And as I told you, few people had ventured out further north from the region of Greece, and they came back and reported that you have areas which are permanently frozen, and that is where you had the naming as frigid zone, which is permanently frozen. But then obviously, this classification which was done was very rudimentary, very, very basic. And it did not solve the purpose of understanding that which portion of the world experiences which kind of climate. And by the 1700s and 1800s, the level of discovery had increased to such an extent that you had the botanists across the world being able to compile the types of plants, the types of vegetation that you come across in many different areas. It was found out that the plant types, they vary even across the similar latitude. Why? Because the rainfall varies. Now, accordingly, in 1870s, you had a French biologist with the name of Candolle. And Candolle, what he did, he gave an entire encyclopedia or a kind of a compilation of plant diversity across the world. Candolle was a botanist. So he gave the entire encyclopedia and a compilation of all types of plants that you find in different parts of the world. The natural plants, the local plants which grow. Now, this was available in 1870s. Then, another 20 to 30 years later, you had Vladimir Koppen, who basically looked at this encyclopedia or compilation which was made by Candolle, and he realized something. He realized that, look, plants, when they grow in an area, what is it that plants require? And why is it that different types of plants grow in different areas? So he was absolutely convinced that growth of plants depends upon two conditions: conditions of temperature, and conditions of precipitation or rainfall. So he was absolutely convinced that, see, any plant which grows in an area, depending upon the type of rainfall, the amount of rainfall, you will have different types of plants which will grow. So that is where he thought about it, that, okay, if I have a record of the plants which grow in different areas, accordingly, I can work upon it and I can decipher the climatic conditions which exist in different parts of the world. It was a different matter altogether that later on people realized that plants, they depend on many other factors. They depend upon the rate of evaporation, they depend upon the movement of the wind pattern, etc. So that is why his classification was later upon worked upon by his students and a few of his pupils. And you had other climatic classification provided by Thorndike. You had the other climatic classification provided by Trevartha. But all those are not important for your general studies. For your general studies, all you need to know is the basic classification which Köppen provided based upon the distribution of plant life across the globe. And his study was based upon the compilation which was given by the French botanist. His name was Candolle. Okay. Now, how is it that Köppen classified the climatic condition? So basically, he used alphabetical letters in order to classify the types of climate. For example, if an area receives rainfall throughout the year, you use a different alphabet. If an area receives rainfall only during summer, you use a different alphabet. If an area receives monsoonal type of climate, that too much of rainfall but in small time gap, you use a different alphabet. If the temperature experienced in one region, for example, you consider the area of Delhi and you compare it with the region around, let's say, Nagpur. Now, Nagpur also experiences high temperature, so does Delhi. But then there will be slight variation in the extent of rainfall, slight variation in how much temperature do they experience in summer months, which is greater, which is lesser. So for all these, he used the various alphabets to classify the climatic types. Broadly, he used the capital letters to classify the zones, right? And as per that, he used A, B, C, D, E. These were the capital letter alphabets which were used. There was another capital letter alphabet, but we'll come to it. So these were the initial capital letter alphabets that he used. He said that, look, when we say A type, this would demarcate a zone which is equatorial, which is closer to the equator. So this would represent a kind of a region around equator in the tropics, that is within tropics. Okay. Then B type. There he also observed, Köppen observed that, look, as we move slightly farther away from the region of equator, we come across desert areas, be it the Thar Desert, be it the Sahara Desert, be it the Rub al Khali Desert, be it the Dast-e Lut, Dast-e Kavir, all these desert areas. Then you have the Gobi Desert. So as you move away from equator, in the southern hemisphere, you have the Kalahari Desert, the Namib Desert, the Botswana. So you have all these various desert areas which are slightly away from equator. So that is where he used the letter B, desert areas. Now, for the desert areas, he was very clear that, look, an area will be a desert only if it is moisture deficient, right? Overall, it experiences a deficiency of moisture availability. And when will that happen? That will only happen when rate of evaporation is greater or much greater than rate of precipitation. And also, as you move slightly further away from equator into the region of the tropics, you also come across high pressure zones. And these high pressure zones mean an absolute lack of rainfall. Which are these high pressure zones? The subtropical high pressure belt. So many of these desert areas, they lie in that zone, high pressure zone. Then came C type. C type would represent temperate or moderate climatic condition. Temperate or moderate type. Which means summer not very hot, summer not very hot, and winter not very cold. Okay, so that is what was referred to as the moderate type, where the summer will not be very hot. The average temperature during summer months would not exceed around 22-25 degrees. And during winter, it would not fall below 8 or 5 degrees. So you have moderate type of climate, which is experienced in the temperate region, beyond the tropics, that is. Then came D type. D type, he used this type to demarcate the areas which represented, for example, northern portion of Canada, for example, the regions of Siberia, for example, other areas which do experience very cold conditions, right? So these areas would generally be far away from the coastline. Because in the coastline, remember, we have seen that whenever we talk about a coastal area, they will never experience extremity of climatic conditions. Because coastal areas will always have the influence of land breeze and sea breeze, due to which the climatic conditions will always end up moderating themselves. So D type would represent areas with very cold winters, where frequently during the winter months, the temperature would dip below freezing point very easily, right? So for example, in the region of Siberia, Canada, etc., those are the ideal cases for this. And then E type is reserved for polar climate, where there is permanent freezing, or the conditions of permafrost as it is referred to. So these were the basic classifications which were generated by, or which were provided by, Köppen. But then he realized something else. He realized that, look, even across the same latitude, you do experience variation in temperature, variation in rainfall with the altitude of a place. So if a place is situated at a higher altitude, like a hill station, a highland, or an upland, generally they would experience lower temperature as compared to the same area along the same latitude, right? Now, that can be an anomaly. How you describe that in a separate zone? You cannot have a latitudinal extent, because hill stations or uplands can exist anywhere. Take the case of Ooty. Ooty, very close to the region of Mysore, Bangalore, and Chennai, etc. Ooty experiences very low temperature as compared to these areas. Take the case of other hill stations, Dalhousie, Shimla, Darjeeling, McLeodganj, all of these comparative and compared to the areas which are at sea level, these experience very low temperature. So for that, he designated another capital letter, and that is H type. H type would represent highland type of climate. Which would mean the climatic conditions experienced in those areas where, due to altitude, they experience lower temperature conditions and a variation in terms of rainfall availability as well. So that is what is H type. Okay, so you have A, B, C, D, E, and H type. These were the broader classifications which were carried out by Köppen. Now here, one has to understand that this broader classification which was done by Köppen, basically, this would not satisfy all the various different climatic zones. Because even when we say region around equator, even if we say that, now the region around equator is very vast. They can have different amount of rainfall. For example, take the case of Chennai, take the case of Mangalore. Both are closer to equator, but both will experience rainfall in very different set of circumstances. Take the case, for example, of Sri Lanka. It is also near equator, but then the weather experience will be very different. The climate experience will be very different. So for that, he started using another set of alphabets and rainfall characteristics. Rainfall characteristics. For that, he used the letters F, M, S, and W. What they all mean, I will give you in the written portion of the PPT itself. But other than that, he also realized that, let's say, in the same zone, it is not as if in the case of B, all the areas will experience the same temperature. Same is the case with C or D. It is not as if the interior of Siberia will experience the same temperature as compared to a region closer to the coastline, right? So that is when the temperature characteristics were represented by the alphabets A, B, C, D, the smaller ones. So based upon all these various different alphabets, he postulated or he carried out the climatic zonation across the world. Okay, so if you take a broader look, first of all, that what do we mean by this kind of a classification? So look at it. A type meant what? Humid tropical climate. Tropical climate means what? Present within the tropics, between Tropic of Cancer and Tropic of Capricorn. Humid means what? There is availability of moisture. Moisture is predominant, it is not deficient. So in these areas, what will you experience around the tropics? Average annual temperature is always going to be higher than 18 degrees Celsius. Always, right? And you have warm and moist conditions throughout the year. Almost in the southern part of the country, that is the peninsular part of the country, we do experience this type of climate, where the average annual temperature is always above 18 degrees Celsius, regardless of how many bonfires you light up during the month of December and January. You will always find the average annual temperature to be mostly above 18 degrees Celsius, other than the highlands. Then B type, dry climate, these are the desert areas. Desert areas. Then C type. C type, what did we look at? Temperate climate, moderate climate, neither an extremity of summer nor an extremity of winter. So mild winters. Average temperature of the coldest and the warmest month will lie between around 18 to 3 degrees Celsius, or at max around 22 degrees Celsius during the warmest month, and the coldest month not lower than 8, 5, or sometimes even 3 degrees Celsius, but not below that. So this is a temperate type of climate, that is C type. This is something which is found immediately beyond the tropics, that is around 40-degree latitude, 50-degree latitude, in those areas. Then as we move further towards the poles, that is in the region around Siberia, Canada, etc., that is where you experience D type, where the average temperature of coldest and warmest month being below -3 degrees Celsius and sometimes above 10, but also it can lie below 10 degrees Celsius. That is the weather climate or the weather conditions and the climatic conditions you experience in Siberia, Canada, etc. Then you further move towards the poles and you come across the polar climate, that is the E type, where you don't have a summer. Throughout the year, the temperature will be below freezing point. So that is why large and massive areas are permanently under ice cover here. So this is basically the broader classification. The sub-classification which he carried out, where he used the smaller letters F, M, S, and W to indicate the type of rainfall or the variation in rainfall experienced within the same zone. For example, F would represent rainfall throughout the year, right? So no dry season. So this would represent rains throughout the year. Through the year. Then M would represent monsoon climate, where you have high amount of rainfall, but concentrated in few months of the year, generally following the summer season. After the summer season, when the land gets warmed up, that is when a low pressure is created and the winds blow through and they bring moisture and availability of rainfall. That is what is depicted as M type. W, winter is dry, right? So W is basically winter dry. That means you receive rains during summer. Rains during summer. Then you also have S. S represents summer dry. That means rains only during winter. Rains during winter. Now, please understand one fine thing. The same thing that I told you before studying the continental drift theory as well. I told you at that point of time, if you recall, that this was not the perfect theory. It went through multiple different revisions. Köppen classification was given in the early years of 1900s. And at that point of time, it was a very basic, very rudimentary type of classification. And after that, this was utilized, this was modified significantly. You had a greater understanding that, okay, climatic conditions vary because of other factors as well. That is when the Thorndike and Trevartha classification, which came later on, they were much more accurate to depict the climatic condition in a region. Moreover, even the Köppen's classification was further significantly updated by his pupils, and you had the Geiger-Köppen classification, you had the Geiger-Pohl Köppen classification. So you had multiple updates which were provided. So this is anything but perfect. This is not at all perfect. So please don't adhere to it and think about that this is the final climatic classification that we live by today. This was done early 1900s, but important for your exam. So this is something that we will follow for general studies, only this Köppen classification. And A, B, C, and D, the smaller ones, refer to the degree of severity of temperature, where it is that the temperature is more severe. Okay. Now, that is the broader classification that we will see. As we move ahead, you also have other classification which is done. For example, in the case of B type, he used the capital letters W, S, and also used the letter K, right? So these letters also he put to use during the classification of desert type of climate, representing savanna, representing steppe condition, representing very dry desert, cold desert areas. So that is what he used. So one by one, we'll take a look at the various different types of climatic classification. This is the broader representation across the map, as you can see. Now here you will see the various different climate types, and they are depicted. Now, overall, if you want to remember this is in an easy way, the easiest way to remember this is to always think that as you move away from equator, you move from A to B to C to D to E, and E is the region of poles. So here you have A type, this is the B type, this is where you have the C type, this is the D type, and this is the E type. Okay. Even in A, you have three subtypes. You have AF, AM, and AW. You don't have an AS. Similarly, BW, BS. Then you have CA, CW, CF, and so on. Now, here, before all of you start getting concerned, do we need to remember all these codes? The answer is no. You don't need to be learning these codes. UPSC has not asked these codes in the prelims examination. UPSC asks you questions like, what are the conditions experienced in equatorial climate? And accordingly, you have the options that you have to select. What are the conditions experienced in monsoon climate? What are the conditions experienced in Mediterranean type of climate? Such types of questions are asked. So code and learning of code is not important. You have to look at the larger picture, that why you have a certain type of condition. Now, obviously, this again is going to be very tedious. This is not an easy exercise to do. And as I told you yesterday itself, this is going to be a very theoretical portion. What I would suggest to you is, I understand many of you have not started your revision process. Many of you have not revised what has happened in the past, what has been taught in the past. So what I would recommend to all of you is, before you approach this particular portion, you should have a proper idea about atmospheric circulation, okay, in the terms of wind movement, and also you need to get an idea about whether these wind movements, they are onshore in an area or offshore in any particular area. For example, consider the region around Great Britain or United Kingdom. Here you will see that the wind patterns that are experienced, that is the westerlies, right? Now these westerlies, they will be in existence throughout the year. And these westerlies, will they be onshore or offshore? In the region of United Kingdom, they will be onshore. So will they bring rainfall or not? Absolutely yes. That is why the region of United Kingdom receives rainfall throughout the year. So once you have an idea about whether a wind system in a place is onshore or offshore, you will be able to decipher whether it receives rainfall or not. Then, shift of the wind with the shift of the pressure zones. For example, take the case of the region around Mediterranean. This area, let's consider this particular area. Now, during the summer season, this is the zone where you will have the subtropical high pressure belt. During the summer season, here you will have the subtropical high pressure belt. So during summer, if this is a region which has the subtropical high pressure belt, will it receive rainfall or will it remain dry? What do you think? It will be dry. Very good. So here in the region of Mediterranean, we can say that summer is dry. During the winter months, what will happen to the pressure zone? Will the pressure belt shift north? Will the pressure belt shift south during the winter months in northern hemisphere? What do you think? They will be shifting to the south, isn't it? Now let us take a look at that. If the pressure belts, the high pressure belt, that shifts to the south here. That means in the region of Mediterranean, now you will observe the movement of westerlies. Now you will observe the movement of westerlies. Now these westerlies along the Mediterranean coastline, won't they experience an onshore wind movement? And won't they experience the onshore winds bringing rainfall? Absolutely yes. So it is because of the shift of the wind due to the shift of the pressure zones, that is why this region will experience rainfall during winter. So if I ask you that what are the climatic conditions when we talk about Mediterranean climate, won't you be able to say that, look, the summers will not have rainfall because of the subtropical high pressure belt, and winters will have rainfall because the existence of westerlies as the pressure belt shifts south, right? That is what is Mediterranean climate. If I ask you that in the region of Britain, what is the climatic type which is experienced? Here you have westerlies. Now, it is also an area surrounded by water body. So let me know about things one by one. Will the region of United Kingdom experience extremity of temperature? What do you think? Will it experience extremity of temperature? Absolutely no. What about rainfall? Will the rainfall be seasonal or will it be prevalent throughout the year? What do you think? Rainfall will be seasonal or will it be present throughout the year? Very good. It will be present throughout the year, surrounded by water body, plus you have the westerlies as well. So that is the characteristic of British type of climate, right? Then if I ask you another question, that in the region of equator, this is the region A type. In the region of equator, mostly you will experience what kind of rainfall occurring in the equatorial region? We have studied under humidity and precipitation. So what kind of condition, what kind of rainfall do you experience in equatorial condition? Beautiful. Convectional rainfall, right? Convectional rainfall, because every day you will have evaporation, every day cumulonimbus clouds, every day in the evening you have rainfall along with thunder and lightning. That is the characteristic of equatorial climate. So just take a look at these basics. Oftentimes, most of the candidates, they will come in contact with us generally around 5 days before the prelims and 5 days before the mains as well. That this is a portion that I'm unable to learn, right? Because the effort is to simply mix it up in a glass of water, gulp it down, and in the time of examination, extract it from inside, vomit it out. But this is one portion which will never be rewarding in that case, because it will have so many different permutation combination of letters that you will be left scratching your head. Maybe you will pick up another subject altogether. So never get embroiled in this particular portion. Always take a look at the basics. For example, equatorial, Mediterranean, for example, British. What do they tell us? That is where the PYQs are concerned with. Okay? Now, let us take a look at all of these types of climatic conditions. Very briefly, we'll take a look at it. And here also, one thing I would like to tell you, that in this, the PPT has been made text heavy, right? So in PPT, you will find a lot of text which is given. So use that text from the PPT and the additional reading materials for your revision, more than sufficient. Not anything more is needed for general studies in your prelims examination. And anyways, this is not very relevant for your mains examination anyways. So use that in the PPT. We have few of you who read, who still read GC Leong and who are great fans of GC Leong as a book. So this is a particular portion that you can study from there. And in fact, this is the only particular portion where GC Leong trumps the NCRT. Right. This is where GC Leong will give you significant detail as compared to NCRT. Now, before you all start panicking and go and buy GC Leong, let me tell you, so much detail is not needed. For general studies, that much detailing is not needed. So restrict your study sources, restrict yourself to the PPT and additional reading materials from this. That is something more than sufficient. Okay. Now, coming to each of these climate types. I knew this question will come. Okay. Again, I will say, in case you are not reading GC Leong, no issues at all. GC Leong is not written for UPSC in mind. Read the basic PPTs, NCRT, and additional reading material, more than sufficient. I hope that is a problem solved, and I hope that question is not asked again. Then we come to the types of climate. We start with Group A. Now here, when we talk about Group A, this is further subdivided into various types. But A type of climate represents tropical, humid climate. Tropical means average annual temperature is higher than 18 degrees Celsius. Humid means availability of rainfall. Moisture sufficiency, humid here refers to moisture sufficiency. That is what is humid. Now, this is largely surrounded around the region of equator. And here also, around the region of equator, it is not as if you will have the same kind of climate. That also ends up varying. So here also you will observe various different types of variation. So you have AF, that is, it lies in the tropics and it rains throughout the year. For example, the region around Amazon, for Amazon forest, that is, the region around the Congo river basin in Africa, the region around Southeast Asia and South Asia in the region around Indonesia, Java, Sumatra, Borneo, few of the island regions, they experience AF type, that is rainfall throughout the year and high temperature throughout the year. Then you have AM. AM means what? Tropical climate, but it will rain only during monsoon season. For example, significant amount of regions in India, right, in the Indian peninsula, you have huge amount of rainfall, but it is restricted to 2 to 3 or 3 to 4 warmer months of the year, right? And then you have AW. Here, this represents winter is completely dry. So you see summer rainfall. So here, obviously, it is different from AM because you don't receive that high amount of rainfall as in the monsoonal climate. So here you will find the growth of grasses, long and large grasses. So here you will find grasslands. Now in A type, you don't find the existence of AS. S means winter rainfall and summer is dry. That is something you don't find in A type. Why? Because when you consider the region of the tropics, there is no such place where the summer remains dry and there is only winter rainfall. There is no such place. Think about it. Because in the tropics, during the summertime, the heating is so much that such an intense low pressure is created in the region, nearby water bodies will have the availability of moisture given to that area. So that is why summer dry in the tropics does not exist. So you have AF, AM, and AW. Let us take a look at the basic characteristics of A type. So tropical humid climates exist between Tropic of Cancer in the north and Tropic of Capricorn in the south. And the sun being overhead throughout the year and the presence of ITCZ, which varies within the tropics only. ITCZ will never cross the tropics in general. Okay? So ITCZ makes the climate hot and humid. ITCZ is the one which will attract a lot of rainfall. Annual range of temperature is very low and annual rainfall is high. Annual range of temperature is low means what? Means little variation during seasonal or between seasonal climate. Jasmeet, but Coromandel coast remains dry during summers. How? Can you say that Coromandel coast during the months of November, December, is it winter? Can you say that it is winter which is experienced in the Coromandel coast? Or will you consider that to be, if you go to the Coromandel coast actually during the months of December, you will feel equally as hot as you feel during the months of May in any other coastline of the country. So that is a kind of a winterless season that the Coromandel coast goes through. You will never come across, if you go to Chennai, you will never come across any individual sporting a jacket during the month of December in the coastline because the temperature is still very high, right? So it is not the case. So the tropical group is divided into three types: AF, AM, and AW. So let us take a look at it. AM represents monsoonal type. AW represents what is also referred to as a grassland type or savanna type. So when we take a look at individual properties, here starting with AF, this is what is also referred to as equatorial type of climate. Equatorial type of climate. Equatorial type of climate will have little variation in temperature, availability of rainfall throughout the year. Observe this. This is for Iquitos in Peru. Observe, this represents the temperature. Throughout the year, the temperature is almost consistent. Same is the case as you were referring to in the region around Coromandel coastline. Throughout the year, the temperature is almost consistent. It will vary between 35 to 25. Rarely will you find a situation where it comes to 22 degrees Celsius or 20 degrees Celsius. That in itself is enough to trigger people wearing sweaters. That is a different matter altogether. But overall, you will see that the temperature variation is very minimal around the region of equator. And that is where you will also find the amount of rainfall every month. This JFMA, this is January, February, March, April, May, June, July. I hope you know the rest. So that is the rainfall which occurs on a monthly basis. Observe, around 25 to 30 centimeter of rainfall occurs here on a monthly basis. So you have annual occurrence of rainfall. And when you have annual occurrence of rainfall on a daily basis, so moisture sufficiency. So what kind of plant types will be observed here? Here typically you will find tropical rainforests. Tropical rainforest, which are also referred to as the evergreen forests. That is something which you will observe here. Okay? Then, here precipitation occurs year round. As I told you, everything has been included in the PPT. Just go through it. Okay, variation in temperature is less than 3 degrees Celsius. In between the various seasons, the variation in temperature is less than 3 degrees Celsius. Humidity is extremely high, and the surface temperature results in formation of cumulus and cumulonimbus clouds in the early afternoon time on a daily basis. So you have daily occurrences of rainfall. This results in high rainfall along with thunder and lightning. The type of vegetation that you will observe is tropical evergreen forest with a dense canopy cover. What is a canopy cover? So when you have a kind of a tree, for example, so this is what is referred to as the canopy of the tree. So when we say that the canopy cover is very dense, means in an area you have so many trees, you have so many various different trees that ground is even not visible. The dense canopy cover has it surrounded it all. Right? So that is something that you come across. So where you find it? Peru, Amazon basin, in South America, both of these, Congo River Basin, the region of Indonesia, Philippines, Borneo, these areas across the world, there you will find the tropical rainforest. These are the areas where you will find the tropical rainforest. In the region of the Amazon basin, this is also what is referred to as the selvas. In the region of the Amazon River Basin, these rainforests, they are also what are referred to as selvas. We will look at it in the map pointing as well, but you should be aware about it. This is the unique name given here, okay, to the rainforest area. Now, here in the region of, here you will find Indo-Malayan rainforest formation in this entire area. The same conditions are observed. Rainfall throughout the year. Very dense canopy cover. From top, if you look at it, the ground won't be visible at all. That much thick canopy is there. So that is the characteristic of AF type. Then we come to AM type. What do we mean by AM? Means you receive significant amount of rainfall during the monsoon. Now, always, as yesterday also we had seen, that monsoon tends to follow the warmest phase of the year. In India, when do we experience monsoon? After enough heating has occurred through the months of March, April, and May. After March, April, and May, they have heated up significantly. That is when we experience monsoon, isn't it? So that is where generally you will find annual rainfall is very similar to that of the AF type, but precipitation occurs within the warmest months of the year. For rest of the year, you won't receive precipitation. It is generally drier. And during rest of the year, there is less precipitation. Winter is generally dry, right? Not always dry, generally dry. Generally. Found over the Indian subcontinent, northeastern part of South America, and also northern portion of Australia. Northern portion of Australia also gets impacted due to the movement of the ITCZ between the various seasons, and that is also the region which also gets impacted by El Nino, La Nina, IOD, MJO. So all those factors, they will influence northern Australia as well. So here you will find in certain areas the presence of evergreen forest, but many of the areas you will find the presence of deciduous forests. Deciduous forest, for those who are not aware, deciduous forest example, you have teak, sal, shisham, sandalwood. Okay, these are the types of trees that you find in deciduous forest. These trees have a unique characteristic which we will study in the portion of biogeography as well. So these forests have a very unique characteristics whereby they will shed their leaves during the dry season in order to ensure survivability. And again, when the rains come, they will have the thriving of the leaves again. They will become green again. So here, the trees shed the leaves during the dry season. During dry season. Okay. Now, Amit, sir, you said tropical rainforest as, but evergreen forest do not receive rainfall on a daily basis. Evergreen forest in many of the areas, they will receive rainfall every evening. Every afternoon and evening, they will receive rainfall. Okay. Example of canopy covered trees, any tree that you see. When you walk out on the road, the tree that you see, what is the shape of the tree? Canopy is not a kind of a fruit that you find only in certain trees. I hope wherever you are living, this is the shape of the tree that exists in that part of the world as well, isn't it? So this is this entire portion. This is what is referred to as canopy of a tree. Okay. So when you walk out on the road, any tree that you see, even the tree that you see in the backyard, it will also have this kind of a broader outline unless and until you are coming across trees of a very different shape and characteristics. Any tree that you consider, let's say even if you go to the region of Kashmir, there also you'll find at least these kinds of trees. Fair enough. This is what will be referred to as canopy. Okay. Right? I hope that is clear. You don't have a separate variety of canopy cover trees. So the same tree in other area will become canopy in equatorial zones. Absolutely not, my dear friend. Please understand. Canopy is when we say the equatorial areas, what is it that it is written? Dense canopy cover. Dense canopy cover means what? if you look at this from above, let's say you have a top view here. Let's say you have a top view here. Would you be able to look at the trunks of the trees at all? Do you think you will be able to look at the trunk? No. What will you be able to look at? Only the canopy of one tree, two tree, three tree. That is it. Why? Because the trees are very dense. Wherever you are living, you will have a park, a zoo, a protected area nearby. There also you will have dense vegetation. That is also dense canopy cover. Dense canopy cover is not restricted to equator. First of all, understand what is the meaning of canopy is an English terminology. Canopy is used even in the case sometimes for umbrellas, that this umbrella has a large canopy. Does not mean that umbrella has been taken to the equator. Canopy means the overlying shaded portion that is present. It is also used when you go for the depiction of tent houses, etc. That also has got a canopy. Architectural buildings have also got a canopy. So canopy is an English term. It is not a biological term. I hope now I make myself clear. Right? Thank you. Now, this is the AM type of climate. Now, here, this is the characteristic of the AM type of climate generally. Here you will observe that, for example, the case is taken of Mangalore in India. Now observe that the temperature varies provides a necessity, a need for water conservation and water preservation. That is an essentiality in monsoonal type of climate. Then we also have AW. AW type is where the winter is dry, so summer rainfall, right? So winter is dry here. So here you will observe that whereas the winter months are completely dry, and it is much drier as compared to the monsoon climate. So here the winter months are much drier for a much larger duration as compared to AM. That means what? For a much larger duration as compared to AM type. So that means what? That basically means in general it will be drier. During summer it will receive rainfall. So here observe, you will find the growth of grasses, the presence of large tracts of grasses with very few trees in between. So here you will find the growth of grasslands. Grasslands with very less trees. Generally, if you observe in many parts of Deccan part of India as well, you will find this kind of condition. if you go to the region around Telangana, if you go to the region around eastern part of Maharashtra, that is the Vidarbha region of Maharashtra, even the northern part of Karnataka, parts of Andhra Pradesh, you do come across these grasses. Now, these large grasses in many of the parts of the world, for example, take the case of Serengeti in the region around Tanzania, right? The part of the entire Masai Mara and the Serengeti protected areas in Africa. There you will find an unending expanse of these grasses with very few trees. Now, as the rainfall occurs only for a few months, after that, there is no rain. So the conditions are very dry conditions. As a result of which, obviously, the trees won't grow. Trees require water. But with the dry conditions, the grasses, they become very dry. And these dry grasses, they can catch fire very easily. So that is why sometimes during the thunderstorms which happen, random thunderstorms which can happen, that can always ignite very huge forest fires. So in this region, rather than forest fires, you have wildfires are very common. And they further play a role in restricting the growth of the trees in that region. That is why in these areas, that is what is referred to as the savanna. In these areas, you will find the presence of the big faunal species, be it the lions, be it the giraffes, be it the zebras, be it the rhinos, be it the hippos, be it the elephants, all of them you will find in these areas because they find a larger area to graze about, to move about, and that is what is the characteristic of these grasslands. So here, this is the characteristic basically for the region of Brazil, Cuba in Brazil. So here, if you will observe that the winter months are generally drier. Okay? Whereas the summer months, they will receive rainfall, even though it is an extremity of it. But generally, you will find that there is lesser precipitation than this as well. Winters are much drier. And the average variation in temperature is minimal in general. So this is the region where you will find them to be present. It is here that you have the Serengeti in Tanzania. You have the Serengeti. You have multiple documentaries, those of you interested in that. You have multiple such documentaries which will help you understand the portion of biodiversity, environment, ecologies as well, as compared to the climatic conditions as well. So you have multiple such documentaries available, which is present on YouTube as well. Always refer to them. That will give you a greater amount of information that, okay, how the animals behave and how the climate tends to behave in a certain part of the world. So you can take a look at documentaries like Our Planet. You can take the look at all of them which have been narrated by David Attenborough. You can take a look at that. You can take a look at the documentary narrated by Barack Obama himself, the former president of United States. So there, Barack Obama talks about our national parks, where across the world, famous protected areas are talked about. So there also you get an idea about the geographical characteristics of the place. So like this, you can diversify your sources of information, which will make you a much well-rounded candidate as compared to the one who has simply learned the book. Okay, so you can do that. Now, here, this is referred to by different names in Venezuela. This is referred to as by Llanos. In the region around Brazil, this is named as Campos. Okay, so you have such type of savanna grasslands which extend in many parts of the world. In India also you'll find prominently in the Deccan region. That is something which you will find there. No, Nitish, prairies in US are not an example of tropical grassland. That is incorrect. Prairies are example of temperate grasslands. Okay. So then we have AW, that is the tropical wet and dry climate. This is also referred to as savanna type. savanna type of climate. See, the names that I am writing here, equatorial type, monsoon type, savanna type, that is the one you have to focus upon. So the wet season is shorter and the dry season is much longer, with the drought being much more severe during the dry conditions. That is where many of the animals, they travel very large distances in order to get access to water. And it is during these dry seasons where many of these animals, they die due to lack of water, and their remains are decomposed, returned to the ground surface, which makes the ground slightly more fertile when the next rains come in. So there has been a kind of a natural circulation of nutrients available in this area. Temperature is generally high throughout the year. Why? Because it is a tropical region. And the diurnal ranges of temperature are greatest during the dry season. What is the diurnal range of temperature? Diurnal range means variation of temperature between day and night. So what does this mean is that during the dry season, the day temperature is extraordinarily high, whereas the nighttime temperature is very cold. Why do you think that is the case? That the nighttime temperature is very cold and the day temperature is very hot? Why do you think that is the case? Between, excuse me, day and night. Very good. Pratyaksh. No humidity to retain heat. And Seni also correct that you have lapse rate is very high. Okay. So because there is a lack of moisture in the air above, that means the land continues to lose heat unabated. Not necessarily, Pranay, it will lead to temperature inversion. Temperature inversion won't be necessarily caused in all these areas. In certain areas, it might be. But then the surface will lose heat at an extraordinary pace. Okay? Now, then tall to short continuous grasslands with scattered trees, and whatever scattered trees are there, they are going to be deciduous. Obviously, during the dry season, there are drought-like conditions, so the trees cannot afford to have leaves. I hope we understand the basic fact that the leaves that are present, those become the sources for loss of water. Whenever you consider any plant or a tree, if they have leaves, let's suppose, the leaves will have pores. Through those pores, water is returned to the atmosphere. Through those pores, water is returned to the atmosphere by a process which we refer to as, very good, transpiration. It is in order to conserve this water, which is already present in scarce quantities. That is why trees will shed their leaves. They will be alive, but they will shed their leaves in the absence or the scarcity of moisture. So, for example, northern and eastern part of India, interior of Burma, Llanos of Venezuela, Campos of Brazil, western Central America, Africa, that is, etc. Then we come to B type of climate. This is a desert type. Here always you will come across a situation where rate of evaporation is always going to be greater than rate of precipitation. So that means there is always going to be a condition of deficiency of moisture, always. Deficiency of moisture. Yes, Seni, that is correct. So here again, in these conditions where the moisture is deficient, can we not say that the daily range of temperature will be significantly high even in this area? Right? Daytime will be very hot, nighttime will be very cold. So daily range of temperature is very high. or the diurnal range of temperature is very high. Okay. So dry climates are characterized by low rainfall that is not adequate for the growth of the plants, large diurnal temperature range, highest daytime temperature. Evaporation and transpiration play a greater role in shaping the type of vegetation as compared to the temperature conditions. Because for the plants which grow in this area, water or the availability of moisture is the limiting factor, not that the temperature is so high. If the moisture is not available, how will the plants go? So that is where you will find the special categories of plants here, which, or the plants in general which grow here, are referred to as xerophytes. They go through multiple different adaptations. For example, rather than leaves, they will have thorns. And the stem, that is something which will store food. Now, in these areas, you also find many of those kinds of plants which suddenly grow. If there is availability of rainfall today, maybe for tomorrow and day after tomorrow, you'll find the plants will grow, they will very quickly flower, and again, after a couple of months, they will die out. Those very seasonal plants, they are referred to as ephemeral plants. Ephemeral plants, which are highly seasonal. Highly seasonal. That is, come into existence only when the rains come. Yes, Nitesh, that is true. Okay, so these are your desert areas of the world. Now, these desert areas, by the way, they are not necessarily going to be hot deserts. You have cold deserts as well. So for that, different characteristic has been utilized. For example, here, the small letter H and K, they have been used, right? So when we say H represents average annual temperature, temperature is higher than 18 degrees Celsius. And in the case of K, average annual temperature is less than 18 degrees Celsius. Then with the B type, you have certain areas, for example, around Mongolia, around the central portion of Europe. You also have areas which do receive some amount of rainfall. They are not completely dry. And you have certain areas in B type which are completely dry, for example, Sahara, then for example, Rubal Khali Desert, for example, Daste Lut, Daste Kavir, for example, even the region of Thar, some parts of Thar Desert. Now, accordingly, B type has also been classified into BW and BS. Right? W means complete desert. And this means semi-arid or a kind of a steppy kind of a grassland feature that you will observe here. So semi-arid. Now why it is semi-arid is because it can receive rainfall sometimes due to the occurrence of fronts in these areas. So fronts will be formed across these areas, won't they? So you have the occurrence of fronts sometimes. So that also leads to causation of some amount of isolated rainfall pattern. So accordingly, you have the BS, that is the semi-arid, and BW, that is a complete desert. BW is further subclassified, BWH, BWK. Same is the case with BS as well. So BW is a desert climate, true desert type which spans and covers close to around 12% of the Earth's total land. Xerophytic vegetation usually grows here. The letters H and K are used as suffixes to represent whether it is hot or whether it is a cold desert. Mostly here you will experience a complete lack of rainfall because of the presence of a pressure zone, the high pressure zone, as well as along with the fact that many of these areas are completely in the interior. So that is why you have continental air which is devoid of moisture. That is why a complete lack of rainfall is observed in many of these areas as well. So this is the characteristic observed in Tindouf in Algeria. So here basically these are amongst the driest places across the planet, low relative humidity, irregular and unreliable rainfall. Observe, when is it that the rainfall is happening here? Minimal rainfall, right? Minimal rainfall. And mostly it is dry. So highest percentage of sunshine for any climatic type that you talk about. Large diurnal temperature range. So these are the characteristics of BWH. Then after that, we have the BS or the steppe or the semi-arid. Steppe is a name associated with a type of a grassland. A type of a grassland which does not grow in the tropics, but which grows in the temperate regions. So steppe represents a kind of grasslands. And these grasslands are of temperate conditions. Okay. So this BS spans for around 14% of the Earth's land and makes up the grassland type. These regions receive more rainfall than their BW counterparts. Why? Because of mid-latitude cyclones, that is, the frontal cyclones. Frontal cyclones. And in certain areas, you can also have the zones of intertropical convergence, even though that is very rare. But you can have that convergence. So this is the characteristic of BSH type. This is for Australia. Observe here, it represents summer rainfall. Significant amount of summer rainfall is observed. That is from November, December, January, Feb, you will have high rainfall. And it is Delhi waters in Australia. So here you will observe that significant amount of evapotranspiration is a contributing factor for vegetation as well. And here semi-arid conditions prevail. Okay, so that is where semi-arid or BS type. Then when we talk about BWK and BSK, K represents cold conditions. K represents conditions when the average annual temperature is lower than average annual temperature is less than 18 degrees Celsius. Okay, average annual temperature is less than 18 degrees Celsius. That is where K is represented. So you have cold deserts of the world as well. In fact, Ladakh is very similar to that of a cold desert. Gobi Desert in the region of Mongolia, that is also a cold desert. So just like you have hot deserts, similarly you have cold deserts as well. So here, the climates are dry because of extreme continentality that is surrounded by landmass from all sides and the effect of higher elevations or greater height. Being located at the center of the continent, for example, take the case of the Mongolian Gobi Desert here. Observe here. If I take you back to the map here, observe this portion. It is in the central portion of the continent. Which wind will be able to reach till here? You will have the presence of mountains all through this area. So the winds will not be able to reach there as well. Even if they reach, by that point of time, they will not have any moisture present, right? So Here, basically, the presence of mountains upwind of these climates can further reduce the moisture availability because of rain shadow effect or these regions lying in leeward side. Okay. Sushri, the difference between cold and hot desert is basically the temperature. When you talk about Ladakh, Ladakh is a kind of a cold desert in many of the areas, the drier regions. Cold desert does not mean you will have snowfall. If there is snowfall, that is a form of precipitation. Okay, so cold desert does not mean you will have snowfall. You will have dry conditions with very cold conditions. Okay, rain shadow effect means we have talked about this, guys. This is your windward side. Windward side. This is your leeward side. In this region, there is a lack of rain. Why? Because the winds become drier by the time they come here. So this entire area has a rain shadow effect. We also have talked about it that larger the mountain height, greater is the area of rain shadow created by that. Okay. So major expanses of mid-latitude desert can be found in the region around Caspian Sea, north of the Himalayas, in the western portion of United States, east of Andes in a narrow zone, and they have a greater range of both daily and annual temperature as compared to the subtropical counterparts, because in many of the cases subtropics, they still have presence of some amount of moisture, whereas in these areas you don't. Okay, so this is, for example, the region around United States. Observe that the temperature is high. Winter temperatures are very low. Around 0 degrees Celsius is the winter temperature in general, right? Summer temperature reaches around 20-25 degrees Celsius. And you have some amount of precipitation which is observed. Okay. Small and capital S and W. Is there any difference, Savita? Absolutely, yes, there is difference. So when we talk about small and small s, it represents the rainfall. Capital S represents the semi-arid condition. Small w means lack of or winter is dry. So that is a savanna. Capital W means deserts. Okay. Why cold deserts poses low temperature? Because of the latitudinal conditions, because of the altitude conditions. So just because the temperature is low does not mean you will have vegetation. Lack of vegetation in general due to lack of availability of moisture, that is what creates a desert. Okay. Very little, Devansh, almost negligible. What is meant by wet summer, Siddhant? That refers to that during summer you have rains which are received. What is the major difference between BWK and BSK? BWK is going to be much drier. It is going to give you an idea of a proper desert. BSK will have grasses in certain regions, Amit. Anil, absolutely agreed. This is too much of a theoretical portion, but now we are left with only C and D type. We will finish it very quickly. K represents, Kivika represents the magnitude of temperature in the desert areas. If it is higher, average annual temperature is higher than 18 degrees Celsius, you use the letter small h. If it is lower than 18 degrees Celsius, you use K. Okay. So now let's take a break, guys. I hope after this much theory, a break is very much required. So let's take a break, and we'll take a break for 10 minutes. Now, again, I will tell you guys, this coding is not required to be learned. All of you who have started to perspire because of this, please understand this coding, this code that you need to learn, that you see. This is something not required. Okay? You don't need to learn the codes. All you need to know, Savanna climate, what happens? Equatorial climate, what happens? Then desert climate, what happens? British climate, Mediterranean climate, what is it that we experience? Okay, so we take a break and we'll be back by 6:45. A confirmation for the audio, please. Thank you. Sushri, is this required for optional? Very much. In optional, you find detailed questions that explain the Köppen's classification. How is it different from Trevartha and Thorndike? So, for those of you who are preparing for optional, for those of you, you need to learn the codes as well. Whereas for the general studies, the guys who are only touching this subject for general studies, you are relieved of that. You don't need to learn the codes, the various different codes. Then Himanshi, you have a question. As equatorial forests receive rainfall throughout the years, so trees do not shed their leaves. See, it is not as if the trees will not shed their leaves. Why they are referred to as an evergreen forest is, for example, let's consider a large forested area. Maybe few trees will shed their leaves, but the entire forest will still give you an appearance of green because all the trees won't shed their leaves at the same time. Then other set of trees, when they begin to shed their leaves, the earlier ones, they will sprout again. So that is why always they will give you an appearance as if it is green, hence the name evergreen. Okay. And Devansh, AW will have higher seasonal variation of temperature because there is no vapor to retain heat. Yes, that is true. Sushri, hot and cold desert, when we talk about it, is desert is what? Is it that we refer to as desert? It is a different matter altogether. That since our childhood days, whenever anybody mentions the name of the desert, we immediately start thinking of sand dunes, camels riding on the sand dunes, Sahara Desert, Thar Desert. But you have deserts with very low temperature as well. For example, if you take a look at the eastern portion of Ladakh, where you have frequent clashes going on with the Chinese PLA, etc. Now, if you take a look at the images which are circulated, the videos which are circulated, you will find that those are absolutely barren, right? The temperature is very low, but there is no vegetation. So it is a cold desert where there is no vegetation due to lack of precipitation, but the temperatures are low. Okay? Right? And Adeline, for how to open PTS 2023 to give mock test, kindly contact the mentorship line or write to us. They will give you a significant detail about it. Okay. Gobi Pratyaksh again receives very little amount of snowfall. Whenever it will receive snowfall, you will find sprouting of few of the small shrubs and plants here and there. But then again, mostly it will give you the appearance similar to that of Ladakh, right? Xerophytic salam is that kind of a vegetation which typically is observed in the desert areas. For example, cacti, the cactus, where you have certain adaptations that they bring about, fleshy stems where they can store food, the green coloration of the stems. So that is what is the xerophytic vegetation. Okay. Siddhant, the rain that you are receiving in Delhi right now, it is a part of the low pressure system which is still traveling from the region of Mediterranean. Okay, so those low pressure systems, they create the conditions which bring about rainfall. Pranay, that is very true. The Köppen classification helps you understand environment ecology much better. Then we come to group C type of climate, which is also what is referred to as the Mediterranean, the temperate type of climatic condition. So in this, you will have moderate climatic condition. Moderate climatic condition. That is, the winters are not very cold and the summers are not very hot either. So you will have the temperature in between around 10 to 20 degrees Celsius in most of the cases. Here, when we talk about it, so here you have hot and humid summers and mild winters. It extends generally in the temperate region beyond the tropics. That is 30 to 50 degree latitude northwards and southwards from the equator. And these are typically the eastern and the western extremes of the continent. Now, when we say eastern and western extremes of continent, how does it help us understand the climatic conditions? This tells us if any area is on the eastern extent or the western portion of a continent, that means there is presence of onshore and offshore winds. Presence of onshore and offshore winds. That is something which prevails in this particular area. Sometimes the summer months may feature convective thunderstorms, the convective rainfall, and winters may observe or may experience the mid-latitude cyclone or the frontal cyclone, which is also the frontal or the extratropical cyclone. Frontal cyclone. That is also something which you experience sometimes. So here typically observe it mostly, for example, even if you consider the region of United Kingdom. So all these areas typically are across the coastlines or the extremities. So here the temperature or the climatic condition that you experience is what is referred to as the British type. Now we have seen in the case of British type already. A quick revision. When is it that rainfall occurs in the British type of climate? Let me see if you recall what we studied in the initial portion of the class. When is it that rainfall occurs? Thank you very much. Throughout the year, due to westerlies. Then, for example, this is what is Mediterranean type. Mediterranean type of climate. Here, when is it that you will receive rainfall? During the summer, winter, or throughout the year? Beautiful. During the winters. Then this is what represents China type. Now, in this portion, because it is China type, in this portion, generally you will experience. Now, observe this. We will look at the text as well later, guys, so don't start panicking about it. So, typically, during the winter months, you will have the presence of the subtropical high pressure belt, isn't it? Here, around 30-degree latitude, you have the subtropical high pressure belt. So, generally, winters will be dry. During summer season, we know that over India, during the summer season, which pressure zone passes over India, over northern part of India? Which pressure zone? ITCZ. So during the summer, sometimes the ITCZ comes through here in this portion. Now, if the ITCZ comes through, that means you will have the trade winds, northern trade winds as well. You will have convective rainfall in this portion as well. So when is it that it is going to receive rainfall? During the summer months. Winters comparatively are drier. Okay. Almost something similar is observed here as well in the region of eastern portion of United States. Now this is a region which surrounds the Gulf of Mexico. This is where you have the Gulf of Mexico. Gulf of Mexico. And that is where this is also what is referred to as the Gulf type of climate. Okay. Then this is the portion here which exists in the natal region of South Africa. This is also what is referred to as natal type of climate. And in fact, the similarity of conditions observed in Argentina and Australia, that also gives them the name natal type of climatic conditions. So that is why in C-type you have the sub-categorization which is done. Overall, this can be broken into CFA, CFB, CS, or CW. CFB is what we refer to as the British type. Okay. Now, let us take a look. So when we talk about CFA, so here it lies on the eastern part of the continent in subtropical latitudes generally, the Gulf type of climate in general. Here also, no dry season because the trade winds in many of the cases become onshore here, because this region air masses are unstable and cause rainfall throughout the year. Examples: eastern part of United States, some parts of southern and eastern China, also southern Japan. Wherever you have the presence of onshore winds, you will have CFA. F here, my dear friends, F always will represent rainfall throughout the year. Whenever you find F, rainfall throughout the year. Annual range of precipitation vary from around 75 to 150 centimeter throughout the year. This is the characteristic. So basically, as you move further inland, closer to the coastal areas, you will receive rainfall due to instability of air. But as you move inland, the amount of rainfall reduces. Okay, in the case around China, Japan, etc., oftentimes you observe the reversal of wind pattern in these areas. Okay, so it is here also that you will experience sometimes, here also sometimes you will experience this, here also you will experience this sometimes, here definitely you will experience it. Then CFB, or the marine west coast climate, which is also referred to as the British type. So here it is slightly polewards from the region which experiences Mediterranean type of climate. So here, northwestern Europe, west coast of North America, north of California, some parts of Chile, Australia, there also you experience. Now, due to marine influence, the presence of water body nearby, the temperature is moderate, and during winter, because the temperature is moderate, the same latitude, if you talk about areas which are in the interior, they will experience slightly colder conditions. Because of the marine influence, the temperature conditions become moderate in these areas. Annual range of precipitation is significantly higher. Winters are milder, and there also, due to mid-latitude cyclone, etc., you receive heavy rains. So this is observed in the region of London. Observe here, rainfall on a monthly basis. On a monthly basis, you will be observing rainfall. Similarly is the case with British Columbia, Vancouver in Canada. That is again something where you will experience this type of climatic condition. Right? This is your CFB. CFB. Okay? So that is your CFB. Generally under the influence of westerlies. Generally under the influence of westerlies. Okay? And you have CS. S means you have summer dry, that is winter rains, that is the Mediterranean type of climate. So here, why is it that the summer is dry? Because during the summer, this comes under the influence of the subtropical high, means lack of rainfall, lack of rains due to high pressure condition. And as the pressure belts, they shift slightly to the south during the winter months. So you have the westerlies, which bring onshore winds, which cause rainfall in winter months. That is Mediterranean. Now, in these areas, typically, you'll find the growth of fruit orchards. Fruits are grown significantly. So you have a lot of fruit orchards, various different types of citrus fruits, olives, etc. that is grown. Then precipitation is heaviest during the winters due to mid-latitude cyclones as well. And temperature in summer is around 25 degrees Celsius and in winter below 10 degrees Celsius. So here, growth of fruits and fruit trees or fruit orchards is observed. That is why if you take a look at the southern coast of Italy, the region around Greece, the region around southern France, the French Riviera area, all these areas, you will find a lot of grapes are grown and a lot of various different fruits are also typically grown in that area. So this is Mediterranean type of climate is where you will find a lot of such different types of fruit orchards to be growing. Then we have the CW. That means winter is dry. This is the China type. Dry in winter, hot in summer. And here, typically due to the movement of ITCZ, you end up receiving summer rains. So summer rains are caused due to movement of ITCZ. Okay. Then we come to D type. So these are present in the interior areas. For example, consider the location of United Kingdom, where you experience British type. Now we have seen that the temperature and the climatic conditions are moderate in that area. Why? Because you have the influence of the water body. But across the same latitude, if you move interior in the region of Poland, Russia, etc., you will find that the conditions are much harsher. Same is the case with Canada as well. So winters are much harsher. So these are the areas further beyond the sea type in the interior of the continents where winters are much more harsher. So cold snow forest type climates occur in large continental area in the northern hemisphere between 40 to 70 degree north latitudes in Europe, Asia, and North America. Why not in South America? Because in South America at these latitudes, you don't have significant landmass which is present. Summers are typically warm but can also be cool, while winters are cold. Okay, so if you take a look at it here also, so the coastal areas, that is the coastal areas, if you consider DF, this generally is observed in coastal areas. That means rains throughout the year. Okay, then you have DW and DS as well. As you move to greater latitudes closer to the poles, it will become much more colder. So cold climate with humid winter occurs polewards of the British type or marine west coast climate and mid-latitude steppe that we have studied, the BS type. Winters are cold and snowy. The frost-free season is very short. Frost is what? When due to excessively low temperature, you have freezing which occurs. Rather than dew, you have development of frost. Annual ranges of temperature are large in many of the cases. Polewards, the winters become much more severe. So here you have the example of this, DF. Observe rainfall occurs almost throughout the year. This is again Winnipeg in Canada. Then DW, here dry winters observed generally in the northeastern portion of Asia around the region of Siberia. Now during winter, you have the development of a high pressure cell. Remember, yesterday we were also talking about the existence of pressure zones in various parts of the world. And basically during monsoons also we discussed that some part of the Tibetan wind goes and settles in the region around Siberia. So that exists even during winter. So during winter in Siberia, you have development of anticyclonic conditions. And anticyclonic conditions mean absolutely lack of rainfall. Lack of rains. And it's weakening in summer, due to which you observe a reversal of wind direction. That is the monsoon type reversal of wind, which brings some amount of precipitation. Look at it. The precipitation is very low, 15 to 12 to 15 centimeter only. If this much amount of precipitation occurs in India, that will be a very hot and a very dry desert. But because we are in very higher latitudes, closer to the poles, even this much amount of precipitation is enough to support the growth of vegetation in these areas. That is where, as you move closer to the poles, you don't necessarily need that much amount of rainfall as you need around the region of equator to support the growth of trees. But here, this much amount of precipitation in itself can support the growth of vegetation. Then finally, we come to the E-type, that is the polar type. So this is something experienced again in northern portion of Canada. This is again something that you observe in the region around Greenland. This is again something that you observe in the northern portion of the Eurasian landmass and also in Antarctica. That is the polar type of climate. Now here, if I ask you a question, in the region of Greenland, where you will find moderate conditions, the coastline of Greenland or in the interior of Greenland as well? Let me see. Coastal areas of Greenland? Perfect. So when we say coastal areas of Greenland, even though that lies in the polar region, but because of the influence of the water bodies nearby, during the summer months, those areas tend to become ice-free for a very short duration. Even though the areas on the lower level, they are frozen. That is, the subsoil is frozen, but the topsoil will become ice-free. And that is something which is observed in certain areas. So polar climate exists poleward beyond 70-degree latitude. Temperatures are usually low throughout the year. Warmest months see the temperature less than 10 degrees. In fact, in the extreme polar conditions, even during warmest month, it will not reach 0 degrees Celsius, right? Usually occurring in the northern coastal regions of North America, that is north of Canada, Asia, Europe, Greenland, and Antarctica. Here, it is again divided into two types. You have ET, that is tundra. Tundra is because of the types of vegetation, where during summer months, when even some areas become ice-free, so here you have mosses and lichens, the small growing shrubs, etc. That is something you will observe here. Now, this is the region of permafrost, where the subsoil is permanently frozen. Now, let me ask you a question and let me see how many of you remember this. So, in a region where the subsoil is permanently frozen, if there is excessive amount of precipitation which occurs in that area, will there be a mass wasting which will occur or not? If yes, what kind of mass wasting will you observe in these areas? Beautiful, very good. Seni, Devansh, Pranay, Abhishek, Vaishna. Very good. Shivani, Ravi. So in these areas, you generally observe a kind of a mass wasting that we refer to as solifluction, where the topsoil becomes fluidic and tends to flow because the subsoil is permanently frozen. Very good, guys. So during summer, the tundra regions have a longer duration of daylight. During winters, many of these areas, they are under permanent darkness as well. So this is where across the coastal areas, you will experience this. Coastal areas. Tundra type of climate. Tundra type of climate. And in the interior, you have permanently frozen. What is also EF, as we will study. So this is the tundra type of climate, ET, and here observe that the summer temperature is how much? Around 2 to 5 degrees Celsius is the summer temperature, whereas the winter temperature easily in the range of minus 25 to minus 30 degrees Celsius is something you will observe. Okay, so that is in ET. When you go to EF type, here surface is permanently covered in ice or snow. And Which areas? Antarctica. Which areas? Interior of Greenland. Permanently frozen. No summer season. Right? So even in summer, the temperature is below freezing point. Almost negligible precipitation is received. If you look at the readings of the weather station at McMurdo in Antarctica, observe that even the warmest of the months, that is the summer season, even in the summer season, that is during December and January, the temperature is around -5, right? Winter temperatures easily reach -30, -40, sometimes even beyond that. That is your polar climate. Now, let us take a look at the types of questions which are asked from this. This is your broader Köppen classification. Again, I will give you the basic idea about how to remember all this. First things first, in any map of world geography, or even for Indian geography, if you want to explain climatic condition, equator should be drawn. Here, closest to the equator, you will find A-type climate. As you move slightly further away, B-type, B-type, B-type climate. Here also A-type. As you move further away from the poles, C-type, 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 C-type. Right? As you move further away, D-type. As you move further away, E-type. So that is how closest to the equator A, B, C, D, and E. So use this and then you will have an ease of understanding. But still, I would tell you, please don't end up learning the codes for general studies. Not at all required. Look at the type of questions which are asked. So we'll start with the first question. That is, the seasonal reversal of winds is the typical characteristic of E-type, Amit. Example, in southern hemisphere, you have Antarctica. Abhishek, you are overthinking. And when candidates, they start to overthink in the exams, that is when they fetch negative marks. So don't overthink. Good. So the answer in this case, seasonal reversal of winds. That is monsoon climate. Reversal of winds means what? It is blowing here, and in the next season, the wind direction will revert. In the Mediterranean climate, do we have that? We don't have that. In the Mediterranean climate, you have the existence of winds, where earlier you had a lack of winds, now you have the existence, so there's no reversal. In equatorial climate, there is no seasonal change. So the answer will be C, right? Then, consider the following statements. This is statement 1, this is statement 2. Now, the winds, consider these statements, guys, and which of the statements given above is or are correct. Okay, I'll give you 30 seconds and let me see whether you commit the silly mistake that many of the candidates they do in this question. Very good. Beautiful, guys. Still, many of you have committed the same silly mistake that I was thinking about. So the winds which blow between 30° north and 60° south throughout the year are known as westerlies. They are not known as westerlies. In fact, there is no wind system between 30° north all the way to 60° south. Either 30° north and 60° north, or 30° south and 60° south. It is here where UPSC just changed one letter, causing a lot of negative marks. So this is incorrect. Then, The moist air masses that cause winter rains in the northwestern region of India are a part of the westerlies. They are brought in by the westerlies. That is correct. So the answer is B2 only. Which of the following is a characteristic climate of the tropical savanna region? Rainfall throughout the year, rainfall in winter only, an extremely short dry season, a definite dry and wet season. This is a very easy question. This, even if you don't, if you even if you have just looked at it briefly, you can easily come at the solution because the other options can simply be counted out. Very good. So here the correct answer is D, a definite dry and wet season. Rainfall throughout the year is observed where? AF type, right? Rainfall only in winter, not observed in A type, or tropical conditions don't observe this. Extreme short dry season, again, sometimes in AM type, but for tropical savanna, the dry season is much longer. The wet season is much shorter. Then, consider the following statements. The duration of the monsoon decreases from southern India to northern India. The amount of rainfall in the northern plains of India decreases from east to west. Beautiful. So here, duration of monsoon decreases from South India to North India, correct? Because monsoon reaches last in North India and withdraws first from North India. So duration of monsoon in North India is the smallest. Amount of annual rainfall in the northern plains, they will decrease from east to west because you move away from the moisture source. So the answer will be C, that is 1 and 2. Now, during a thunderstorm, the thunder in the skies is produced by the meeting of cumulonimbus clouds in the sky, lightning that separates the nimbus clouds, violent upward movement of air and water particles. So I think I'll give here 15 seconds. 30 seconds gives you a lot of time to commit mistakes. Remember what we studied about lightning and thunder. Okay. Majority of you have given the incorrect answer. Why is it that thunder is produced? Thunder is produced due to sudden expansion of the air. Sudden and violent expansion of air because of heating which occurs due to lightning. That is why thunder is produced. So none of the above produces thunder. Why many of you would have committed mistakes here is that I understand many of you would know why thunder occurs. But upon looking at such kinds of option statements, many of the times, generally candidates, one feature is mostly common is, for most of the candidates, one feature is common is that low on confidence. So even if we know something, we see that, okay, such detailed options are given, maybe I don't know it, whatever is given is correct here only. So that is why many of you commit mistakes here. Be confident, don't be overconfident. Okay, then this is a question we have already done. Seasonal reversal of winds is a typical characteristic of. Then this is another question where a characteristic is defined and the type of climate is asked. So each day is more or less the same. The morning is clear and bright with a sea breeze. As the sun climbs high in the sky, heat mounts up, dark clouds form, then rain comes with thunder and lightning. But rain is soon over. Which of the following regions is described in the above passage? So 15 seconds again, I think will work. Yes, Sini. This is again one of the easier questions that you will come across. Very good. So here you have the answer as B, equatorial type of climate. Why are dewdrops not formed on a cloudy night? So A, clouds absorb the radiation released by the Earth's surface. Clouds reflect back the Earth's radiation. The Earth's surface would have low temperature on cloudy nights. Clouds deflect the blowing wind to ground level. Why are dewdrops not formed on a cloudy night? Correct. Pratyaksh, Abhishek, finally, Abhishek, you are correct. True. So see guys, these are the level of questions which are asked in the prelims. Okay, so please don't make it larger than life when you are preparing. That, oh my God, what I have to study, from where I have to study. These are the conceptual questions which are asked in the prelims. Very good, beautiful. So basically, due to cloud cover, what do you have? You have the clouds. They will re-radiate back the terrestrial radiation, due to which the temperature will rise. Temperature here will rise, due to which lack of dewdrops. So the answer will be B. Okay. That finishes finally our portion of climatology. The portion that we have completed is the most important part. So the leaderboard, for a couple of seconds I will show. Okay. Then here, the portion of climatology that we have completed, that is going to be very important for your mains exam, for your prelims exam, regardless of the question distribution that you observe, regardless of the topic distribution that you observe, you will have the conditionalities where climatology is always necessarily asked. And if you look at the recent trends, you will find that UPSC has been asking questions from climatology which combine 2 to 3 concepts. For example, remember the PYQs that we had discussed, where you had a question for jet streams, tropical cyclones, and the feature of the eye of the cyclone. So you had multiple such concepts included in one question itself. So that is where you have to understand that if the concepts are in place, rest of the geography will already fall into place. See, if you understand the climatic realities and the climatic conditionalities, you will be easily able to understand which crops will grow in an area, because you know the requirements of the various crops. You will know the requirements of the various crops. You will also be able to know that what kind of forests are to be found in different parts of the country, obviously, because forests depend on rainfall. So climatology helps you understand a lot of factors. And that is the portion we have finally completed. Now we come to the portion of oceanography. But before that, a basic question, a question which I generally ask after discussing PYQs. How many of you felt comfortable in dealing with the questions? In the sense that you might have it incorrect, but you were not thrown out of your place. How many of you felt comfortable? Good. Very good. Yes, the questions are normal. It is not as if a geographer will come to explain these kinds of concepts to you. They don't expect you to become a geographer. Okay. So they want you to study only that much which is required to clear the exam, and carry out on with your job. Okay. So I hope that this is something which is comfortable to you, because the level that we have attained in reading the various concepts, I can assure you that the level of questions will be much lower than that. That was the only and the entire effort of raising the level of discussion to a level, to a certain stage, where we are not concerned with the fact that okay, sun rises in in the east, sets in the west, where is the sun moving, etc. So that was the basic fundamental and the basic reasoning of increasing the level of discussion. I hope now, once you have finished this, remember in the first session of climatology the level of doubts that you had. Many of us were even concerned with the fact that how is he saying that the earth is round and we will have different seasons. Now we have candidates who can easily distinguish that where jet streams occur and where they will cause rainfall or not. If you have reached that level of confidence, that is all that is required. Just revise it. Don't let this become very old information that I will revise in December. No, revise it immediately, so that one or two quick revisions you carry out, no need to look at it again for almost 3 to 4 months. Okay. Now then, Arindam, I am much uncomfortable for understanding of language. See, if you want to improve your language and your level of understanding of this, there is no escape or no shortcut other than reading. All of you who want to improve your language, read. Read as much as possible. Daily basis newspapers, especially those who are weaker in language, you should read the entire newspaper. Newspaper is the best source of reading material. Then you have various other books that you read across. So all these, they will make you more proficient with language. And I tell this story to almost all the students. Oftentimes they get demotivated that my level of English is not good, my vocabulary is not good, maybe I'll get exposed during the time of interview. How will I manage? I'll tell you the story, the same story that I tell most of the students, that one of the people that I know, basically, he was from the Odia background, okay, and he wanted to appear in English medium. So on a daily basis, you would find that person with the newspaper early in the morning, sitting in the library. Early morning, you will find that person looking through the dictionary, English to Odia, and then again, he would write it down somewhere just so that he could understand. He could not even understand the basic book. So he worked that hard. Eventually, he attained a double-digit rank. So if you want, if you persevere, you can achieve, provided you are ready to work harder than the others. You need to work a bit harder than the others, but obviously the prize at hand is also so great. So here, now we come to the portion of oceanography. In oceanography, we study about the oceans and the various different circulations which happen in the oceans. What is the prime purpose of studying oceanography for us is very basic. That look, when we talk about planet Earth, we have discussed one particular fact in climatology as well, that the region around the tropics, these are heat deficient or heat surplus areas. What do you think? These are generally heat surplus. That is, year after year, they receive greater amount of heat as compared to what they can lose, right? So they receive more solar insolation. With the help of atmospheric circulation, that heat is distributed to the colder areas as well. But here comes the role of oceans as well. Oceans also significantly play a role in distributing that heat to the other areas. So, study of these oceans is very important. Oceans, anyways, they consider or they basically cover close to 70% of the area across the planet Earth. Many of the portions of the oceans, they are still not explored. We have not managed to explore majority of the portions of oceans when it comes to the ocean depths. Within the oceans, you have multiple level of circulations. Circulations which happen on a horizontal level, circulations which happen in a convective level, vertically, Even vertically, you have multiple circulations happening at the depth. So all these are very vital for the survivability of life and biodiversity across the planet. And that is why oceans are important. So how is it that we are going to study these oceans and oceanography? So first of all, we'll study about the basic, that is bottom relief. Bottom relief features. What do we mean by bottom relief features? What constitutes the ocean bottom? What is it that we refer to as the ocean bottom? Then we will study about physical factors or physical features. Of ocean water. Ocean water. This is where we will study about temperature, salinity, and together these two will help us understand density of water. Then we will be observing and studying movements in oceans, movement in ocean, and here we will be studying tides, ocean currents, and one portion which we will try to finish earlier itself, that is, nowadays you find a lot of mention of it in current affairs for the past couple of years. A lot of mention has been there, that is thermohaline circulation. Haline circulation. Under the portion of current affairs, I will also ensure that we look at the portion of the complex phenomena such as Atlantic, meridional, overturning circulation. Which is also what is referred to as AMOC. Now, what is it that is relevant as per prelims and as per mains examination? So when you take a look at it, here, these factors, that is going to be very relevant for your prelims. Okay? Even this is going to be relevant only for your prelims. Whereas for your mains, you have ocean currents, which are very important. Even for prelims, by the way, ocean currents are important. Ocean currents are important for your prelims as well. Then for your mains, thermohaline circulations. Once a question has also been asked about the region of or the portion of Sargasso Sea. Okay. You also tend to find questions for corals. Something that you study in the portion of environment and ecology. Very briefly, we will cover here as well. The portion of corals, coral reefs, coral bleaching, very briefly we'll cover here as well. So that is the factor relevant for your mains examination. Okay. And also factors influencing the physical features. Of water. Factors influencing temperature, factors influencing salinity, all those. Okay. So from these areas, guys, again, this oceanography is very much similar to the portion of geomorphology. Why do I say so is, you cannot afford to commit mistakes in oceanography because your competition will not commit mistakes here. In climatology, it is still granted that you have twist and turn that UPSC can provide, a conceptual twist or a conceptual turn that UPSC can provide, due to which you might feel uncomfortable, you might commit mistakes. Oceanography and geomorphology have very direct questions. Direct questions are asked. So you cannot afford to commit mistakes. Even this year, you had a very direct question which was asked. So here, your competition will not commit mistakes because the questions are so simple, straightforward. So that is why you have to get all of them correct. Okay. Vishwa, I don't know nothing about geography, but after this, I'm developed to see IMD website. Very good. Continue this on a daily basis or on a monthly basis. Also, you observe or visit the IMD website. I'll also give you another site where you can take a look at it. You have under this, look at the wind patterns if you are interested enough, if that interests you anymore. So on a daily basis, as the monsoon season is approaching, you can find the wind patterns in this. Type this on the Google along with wind pattern, you will find the daily movement of wind as well. On the from the satellite information, you can look at the development of cyclone and anticyclonic circulation, which part of the world it develops. This will further increase your understanding. See, if your understanding has increased or is increased, I will always help you to carry it further. Okay. Now, when the questions are direct, how to get better marks to provide as many perspectives and interlinkage with climate, with geomorphology, etc., as is possible, and make your answer very crisp. Because when everybody is going to write the same answer, evaluator will not have the patience to read the large theories that you write. So make it very, very crisp. Okay. So we start with the ocean bottom relief. Relief is what? Relief is a feature of topography which indicates any kind of variation which is in existence in terms of vertical and horizontal extent. That is what is relief, right? So when we talk about ocean bottoms, in fact, this map that you see, most of you, this world map, most of you would have been viewing this map since your childhood days, since for the first time that your school made you buy an atlas, since that point of time you would have been looking at this map. But here, have you ever wondered that when we talk about oceans, so from very young days, when you start with your coloring pens and pencil, even if nobody teaches you anything, you know the basics that, okay, water bodies have to be colored with blue. So oceans, you would always color blue. But here also you have various shades of blue. Here, the shades are very different. Very dark blue, very light blue, and a blue with a certain kind of variation. So all this represents a variation which does exist at the ocean bottom. Ocean bottom is not flat. That was our understanding largely till World War II, where we thought that, okay, the ocean surface is featureless. So the ocean bottom will also be featureless. Why will it have variation? That was our understanding. But the ocean bottoms, they are not featureless. They have distinctly varied features. Basically, land under the waters of oceans exhibit complex, varied features, right? So these are formed by the factors of tectonic forces, volcanic forces, and depositional as well as erosional process. How? For example, when we talk about tectonic forces, tectonic means what? You have the building activity due to plate movement. Now there, remember, we had discussed that when you have the tectonic forces in a way that an oceanic crust and a continental crust or another oceanic crust, when they collide, when they converge, what is the geomorphic feature which or geological feature which is created at the boundary zone? What is the name of the geological feature? When there is collision, Beautiful. You have the formation of trenches, right? So for example, formation of trenches, right? Then we also have seen that when you have oceanic landmass starts to diverge, in between them you have creation of a feature which oftentimes extends throughout the oceans. What are they referred to as? They are referred to as mid-oceanic ridges, right? So mid-oceanic ridges can be included in the part of tectonic or can also be included in the part of volcanic. Now, another thing we had seen in the case of volcanic eruption, that is when you have an oceanic crust which goes underneath another oceanic crust, there's a volcanic eruption, and this creates what? Underwater volcanic mountains, and they are referred to as seamounts. So here you will find the presence of seamounts as well, isn't it? Seamounts is something that you will find the presence of. So you have tectonic and volcanic forces which create these. Then depositional forces and erosional features as well. We will study about all of these. But just to give you an idea, let's consider a seamount. It is underwater, hence seamount. If it would have been above water, a volcanic island. But it is underwater, so it is a seamount. Now here, MOR here refers to mid-oceanic ridge. Mid-oceanic ridge. Okay. Now this is a seamount underwater. Now water, what do you think? Water in oceans, will they be moving or will they be static and stagnant? What do you think? Will the water be moving or will they be static and stagnant? They will be consistently in motion. Now when the water is in motion here, now it will also carry out its erosional process. Now over a period of time, these seamounts, they get flattened from top in such a manner that the top portion is completely eroded away. And you have a flat tableland-like feature which is created in fact. So when a seamount is eroded from top, creating a flat tableland-like structure, that is what we refer to as a guyat. These are eroded seamounts. Okay, so depositional and erosional processes, they create, as we will study, continental shelf, continental rise, submarine canyon, guyats, etc. All these are created. Many of them are created. All of these we will study. Okay? Now, here a question can be framed from this area, my dear friends. The question can be, a statement type of question can be framed from here. That is, the oceanic bottom relief features are a sum product of geomorphic processes. Elaborate, right? So a question can be, oceanic bottom relief features are a sum product or are a resultant of geomorphic processes. Elaborate or elucidate anything. Let's say this is of 250 words. So if such a question comes, in the introduction, you have to write land under the waters in the oceans. They exhibit varied features which are a resultant of geomorphic processes such as tectonic, volcanic, or erosional and depositional. Or in place of erosional depositional processes, you can also write gradational process. Gradational process. Right? And thereby you have to elaborate under each one of them that how tectonic forces create the mid-oceanic ridges or trench, how is it that volcanic processes create certain thing, how is that gradational processes create certain things. So that is where you have to understand that this is the variation and this is the entire thing that you have to elaborate. And obviously this will be one of the easier questions where you'll be able to write it out. Now, few of the technical terminologies which are generally associated when we talk about the oceanic areas, few of the technical terms. So here, basically, you have many of the oceanic areas. For example, if I bring you back to this image here, observe this portion. This is where a tiny piece of land joins two larger continental land masses, meanwhile separating two larger oceans. So when you have a tiny piece of land which separates two water bodies while joining to the two other land masses, this is referred to as what? This is your isthmus. Okay. Now, here that is Isthmus of Panama. Similarly, here you have Isthmus of Kra. Isthmus of Kra. Okay. Now, in certain areas, for example, observe here. You have a narrow water body which connects two larger water bodies in general. It separates the land. Here also narrow water body which connects two larger water bodies. What are these referred to? When you have a narrow water channel which ends up connecting two larger water bodies, they are referred to as straits. Okay, that is, this one is Strait of Gibraltar and this one is Strait of Malacca. Strait of Malacca. Very, very important for geostrategic purposes when it comes to India and China. So this is the basic for straits and isthmus, right? Now let us move to the division of the ocean floor. Ocean floor broadly, when we talk about it, you have the presence of continental shelf, slope, deep sea plains, which are also referred to as abyssal plains, as well as the presence of deep oceanic trenches, which can extend to a depth of more than 10 kilometers from the sea surface, which are also referred to as oceanic deeps or oceanic trenches. Besides these, you also find other features like ridges, hills, seamounts, gallards, trenches, canyons, etc. also to be present in the region of the ocean floor. So ocean floor will have a variety of these characteristics which are present. Okay, how many of you missed out what is ocean, what is strait and what is isthmus? See, very simple guys. When we have two larger land masses, land and land, and C and C. So you have this small landmass which joins larger land masses and is separating the two seas. That is what is isthmus. Okay, example of isthmus: isthmus of Kra near the region of Malayan Peninsula, isthmus of Suez, across which Suez Canal has been constructed, isthmus of Panama, across which Panama Canal has been constructed. That is your isthmus. When you have two larger water bodies, let's suppose this is land, this is land, this is water, and this is also sea. So a narrow channel which connects two different water bodies and separates two land masses, that is what is referred to as a strait. So an isthmus is a narrow portion of land which joins two larger continental or larger land masses dividing two water bodies, whereas a strait is a small narrow water channel which separates two land masses and joins two water bodies. That is what is your isthmus, and that is what is a strait. Okay. Now, these are the divisions of the ocean floor that we have to come across and we will study. Overall, if you observe this, you will observe that the land mass here, basically, first of all, what do we mean by a shoreline? Shoreline is the representation of where the water comes about. That is what is represented by shoreline. So this is your shoreline. Okay. This is your shoreline in general. Now you would observe that it is not as if wherever the water starts, immediately it becomes very deep. It is not so. In fact, the slope of the land is maintained for a longer distance. And this is then, after that, it suddenly, sharply increases its slope, right? So you have the slope of the land which continues for a longer duration, and then suddenly the slope increases, the water becomes deeper. This portion is what is also referred to as the continental shelf. This continental shelf is largely carried out or made as a result of deposits. Largely made out of deposits. Deposits coming from where? From the continental areas, through runoff water, through various river systems, through the action of the sea waves as well. So you have this as a depositional feature. Suddenly, at one point, you will find that the slope suddenly tends to increase. Here you will find that the width of the shelf is not uniform. It is very variable. You have certain areas, for example, in the region wherever you will come across an oceanic continental convergence. Let's say you have come across the convergence of an oceanic landmass and a continental landmass. So, across the edge of the continental landmass, you will have what? Fold mountains. Fold mountains. So in these areas where the continental crust immediately starts getting folded, do you think you will have a long shelf area? What do you think? Do you think the shelf area will be very broad in that case? Absolutely not, because the land is getting deformed, it is getting compressed. So the width of the shelf, especially in areas where you have the fold mountains across the coastline, for example, take the case of Andes across the Chilean coastline. There, the shelf is absolutely narrow, in certain areas, even absent. Or, on the other hand, take the case where the land has uplifted over a period of time, or the water has receded over a period of time, or there is a significant amount of deposit happening for a long period of time. For example, if you consider the regions indicated by light blue, this entire region, the shelf area can be as wide as 1500 kilometers from the coastline. It is in these areas where you observe suddenly water becomes deep. Observe here, the water suddenly becomes deep. So wherever there are areas of convergences, shelf will be absolutely narrow. Now, this shelf area, the depth of water is not much, availability of sunlight is there. So here you will observe lot of organisms which carry out photosynthesis. In fact, it is in this portion, in the shelf area, where you will find largest concentration of biodiversity in the oceans. It is here where you will find large concentrations of biodiversity. Concentrations of biodiversity. Very large concentrations. Why? Because the producer community is present. Because the plants are present in this area. Why? Because the availability of sunlight is present. Now, when you have large concentration of biodiversity, many of these marine animals, they will die over a period of time. When they will die, they will get deposited. On top of them, more deposits. On top of them, more deposits will happen. So all these shelf areas typically will consist of, in many of these shelf areas, you will have those marine animals and their deposits in certain areas, which will get compressed over a period of time. And marine animals, when their body gets compressed over a period of time, over hundreds and thousands and millions of years, over that period of time, these marine animal deposits, they lead to formation of what? They lead to formation of fossil fuels like crude oil. That is why shelf area, because of concentration of biodiversity, will also be the one where you will find deposits of or presence of crude oil. Okay, so lot of crude oil. In fact, wherever you have offshore drilling which takes place, for example, in the region around the Maharashtra coastline, we have the Bombay High, where oil is extracted from. Now that is a part of the continental shelf area. So shelf areas are generally rich in crude oil deposits. Then this continental shelf suddenly ends at a point, and after that, suddenly the slope tends to increase. So this portion where the shelf suddenly ends, that is what is also referred to as shelf break. Shelf break. Just to give you an idea, if you consider all the various different oceans, the shelf region, the continental shelf region, constitutes only around 8 to 10% of the oceanic surface. I will repeat. For all the various oceanic area that you consider, the continental shelves represent only around 8 to 10% of the oceanic area. But together, they contribute to close to around 90% of the biodiversity that you find in the oceanic area. That is how relevant and important these continental shelves are. Now, beyond the continental shelf, suddenly the slope increases. The depth starts to increase. That is a portion which is referred to as the continental slope. That is where the depth starts to increase all of a sudden. It is here where you find that due to the motion and the activity of water, you have certain erosional features which are created. For example, submarine canyon. These are very different from your oceanic trenches. These are like your canyons that you find on the land areas, something very similar. So these are eroded surfaces or erosional landform. Now, in certain regions, As the slope ends, the continental slope ends, all the materials that the sea waves have been eroding, they start depositing themselves. And suddenly, the slope which was increasing, it tapers a bit. The slope decreases. This is again a depositional feature that you come across. That is continental rise made as a result of deposits. Rise, continental rise is not something that you will find across in all the oceans. You'll find it in very limited types of oceans where you have significant amount of deposit can be carried out. Only there you will find it. It is not something you will find in all the oceanic regions. Now this shelf, slope and rise taken together wherever they are found, together they form the margin of the continents. It is still very much a part of the continental crust. That is what is the margin of the continents overall. In many of the cases, that is referred to as a continental margin. Beyond this, you have the deep sea plains, featureless flat plains, which comprise of the oceanic crust in many of the cases. That is what is referred to as abyssal plain. So let us take a look at each one of them one by one and let us try to understand their features. So when we talk about continental shelf, a continental shelf is the extended margin of each continent occupied by relatively shallow seas and gulfs, right? It is the shallowest part of the ocean where depth varies between 30 meters to sometimes even 600 meters. Observe this area. This is the shelf area. This is the shelf area. Okay, so it varies in depth in various different parts. Average width is around 80 kilometers from the shoreline. In some cases, it is non-existent or marginal, like the coast of Chile, because you have convergence of the continental and the oceanic plates. West coast of Sumatra, there again, it is almost negligible because there also an oceanic plate is subducting underneath. And the largest is around 1500 kilometers, for example, Siberian shelf in the Arctic Ocean. This is very rich in oil. Very rich in oil and natural gas as well. India also has invested in this area through ONGC Videsh Limited in order to extract the oil or facilitate the extraction of oil in this particular area. Now, this shelf typically ends at a very steep slope, which we refer to as a shelf break. And this is also a source of fossil fuels. Which fossil fuels? Petrochemicals or petroleum and natural gas is something which you find in this area. Then after the shelf break, you come across a steeper slope. That is what is referred to as a continental slope. It generally demarcates the end of the continents, right? And it connects continental shelf with the deep sea plains or the oceanic basins. As I told you, not all the areas have continental rise. This continental rise that you see is present only in a few oceanic coasts. Okay. Now, the depth of the slope in this region, it varies between 200 meter and almost up till 3 kilometers from the surface. 3 kilometers from the sea surface, right? That is how deep it can get. Canyons and trenches are observed here. Oceanic trenches are created as a result of tectonic movement. Tectonic movement. Whereas when we talk about canyons, they are created due to erosional process. How? Let us take a look at it. So when we talk about submarine canyons, over a long period of time, since the geographers had started finding this, since the geographers had started discovering the presence of the canyons, you had a lot of debate and discussion that how these canyons came into existence. Just like in the case of geomorphology, here also you had the geographical community divided into two opposite ends. One significant section of geographers, they would say that, look, canyons underneath, which are created as a result of erosion, there can be only one factor which can create that. What was that? The river which is flowing. The river, observe here. Here you will observe there is a river which is flowing. Isn't it? The river which is flowing, this water, they said, this water will have the erosional capacity that it will erode the ground underneath and create these canyons. So immediately the counter response was, that means across every river we will find canyons? The answer was no. Only across large rivers you will find these canyons. So a lot of time was consumed in studying where these canyons are found, and rightly so. In the case of many of these large rivers, you do find the existence of a canyon-like structure. Observe here. Observe the region, certain areas here where Ganga and Brahmaputra meet. I hope you are able to look at this slightly rough line which is present in the shelf area. I hope that is visible to all of you, right? So this is a canyon. Similarly, in the case of where Indus meets, where river Indus meets the Arabian Sea, there also you will find it. Similarly, where Godavari meets, there also you will find it. Across the world, where Mississippi meets, there also you will find it. So it was understood that canyons, they are formed as a result of erosion at the mouth of the river. At the mouth of the river. Now, but then you had another set of discoveries which pointed out to the fact that, look, fair enough, mouth of the rivers can have these canyons, but what explains the presence of canyons in those areas where you don't have river mouths? And you have significant number of those as well. So again, the kind of explanation which was provided was, might be in those areas a river would have existed in the past and that river has disappeared now and we don't know about it. But then it was not a satisfactory response. So that is when came the entire idea about canyons present in those areas where you don't have the river mouths. And for that, another kind of force was considered. What is that force? That is what was referred to as turbidity. Turbidity current. Now, what is turbidity current? First of all, this term in itself extracted from the terminology turbulence. From turbulence, you get turbid. From turbid, you get turbidity. So turbulent waters is something that you hear in your English parlance, in English language. That is the term you come across, turbulent waters and the turbulent times. India was passing through turbulent times, etc. So what is turbulent? Something which is rough, which is not smooth, anything which is not smooth, right? Turbulent waters means where you have a lot of rapids which are created, water is not in a straight line path. So turbidity current is a kind of a current which is generated interior in the lower portions due to the mixture of all the various different sand particles, gravel, pebbles, rock pieces, everything they mix with it, and that creates a turbidity current. How? Let us see. So for example, let us consider this to be the land area, this to be the shelf region, this to be the slope area. Let's assume here you have the water. Water which is present. Now in this case, here, now I want you to recall from your memories or from your experience when you have visited a coastal area, a sea beach in general, whenever you have visited that place or observed this on video, you would have basically observed that when the waves come in, they bring in some materials, but when the waves they retreat, what is also referred to as a backwash, when they start going back, they carry a lot of materials along with them. Many of the times it would have happened that you leave a kind of a light material closer to the coast, closer to the waves, and the waves can carry them, right? Similarly, the waves will carry a lot of sediments, lot of sand particles. Now, all those sediments, sand particles, etc., they mix and they are carried away. Now, these are carried away by the water. So the water induces a kind of a force here. This includes a mixture of sand, pebbles, rock pieces, etc. So obviously, it is not something which is going to be smooth. It is not something which is going to be very plain. It is pulled back by water, and the shelf area will have a slope leading towards the deeper part of the ocean. Now, if anything is present on the slope, what will be the natural tendency? Won't the natural tendency be to slide down under the influence of gravity? So, under the influence of gravity, they start moving. They start moving, and all the while they rub against the surface, the sea surface. They keep on rubbing against the bottom surface of the sea. And that is when oftentimes they gain a speed of close to around 45 to 50 kilometer per hour. So these often gain a speed of 45 to 50 kilometer per hour. This is what is referred to as a turbidity current. Current because it induces a certain directionality of flow. In a certain direction, the materials move in a certain direction. Now, as they start moving, they keep on rubbing against the ground surface, and eventually you will find that repeated motion day after day, month after month, year after year, centuries after centuries, thousands of years continuously, if it happens, it will create an erosional structure. This erosional structure that you see. Now, depending upon the flow of these materials, there will be greater erosion or lesser erosion with narrow wall-like features on both ends, on both sides, and that is what is referred to as a submarine canyon. So that is how the turbidity current is able to create a kind of a submarine canyon. So again, I will repeat, what is a submarine canyon? So basically, these are erosional structures created in the region of the shelf slope area. Why? Because generally it can be caused because of two reasons. One, by lying on the mouth of the river, so the river action can cause that erosion. Or in certain cases, you can also have the wave action carry back some amount of pebbles, sediments, gravel, rock pieces, etc. And as they are carried back, they will continuously rub against the slope, and thereby they are able to create depressions, eroded depressions of sort. That is what we refer to as submarine canyons. Then, after this, we find the presence of deep sea plains, which are also referred to as abyssal plains. Abyssal plains. Abyssal plains, again a term taken from your English literature, English language rather, abyss, right? You would have read about the utility of that abyss, that that individual lost all temper or lost all bearings, and after that it was like falling into an abyss, something which has got no bottom. That is what abyss is used for, something which has got no bottom in general. The language usage I'm talking about. Abyssal plains or deep sea plains, just like what you have on the ground surface, they end up representing flat, featureless portions underwater, large, flat, and featureless portions which extend for hundreds and thousands of kilometers. On an average, the depth in these areas vary between 3 to 6 kilometers. And here you'll find fine graded sediment like clay and silt. So obviously at this depth, light is not something which reaches here. So here you have no availability of light. No availability of light. Right? Now, when you don't have the availability of light, that is what is referred to as aphotic zone. It is in permanent darkness. Many of these areas have not experienced sunlight since time immemorial. So the species which you find in this area, they are also very unique, and specifically the species, they have developed and adapted themselves to live in areas of permanent darkness. So there you will find certain kinds of fishes which use bioluminescence, whereby they are able to emit light from their own bodies in general. Okay, and there you will find certain species of fishes which have very narrow body so that they can withstand the huge pressure exerted from top. They will have very large eyes, hardened skulls, all to look into the darkness and withstand the heavy pressure. Such kinds of species which live in these abyssal plains or the deep sea plains, as you will study in environment and ecology as well, they are referred to as benthic species or benthos. Okay, so here you have the special species that are benthos. Species that is when they create these deep trenches. And these are, again, they can extend almost up till 5 kilometers, 8 kilometers, 10 kilometers beyond or underneath the sea surface. Right? So all across the region of Pacific, you will find endless number of trenches. That is where you have the presence of the oceanic trench. Mariana Trench is present where? To the east of the region of Philippines. That is where you have the presence of Mariana Trench. So this is the broader representation of the ocean bottom relief. Observe, you have the shelf area, then suddenly it increases, slope, then you have the abyssal plains. Meanwhile, you might have certain seamounts or the volcanic islands, and then you have a trench, again a kind of a landmass. So this is the representation of your ocean bottom relief. Then we come to the oceanic temperature. Now, oceanic temperature, when we talk about here, it is relevant for your prelims perspective. For the prelims examination, this is something which is relevant. Okay, you can find questions for variation in oceanic temperature. How does the oceanic temperature vary from one place to another? That is something you can find here. Now, something that we studied while studying about El Nino, La Nina cycles. What is the main source of heat for these oceans? What is the main source of heat for these oceans? Very good. It is sun. So sun is the main source of heat. So the topmost area in general will be the warmer one. And as you start going to the lower regions, the temperature will reduce, isn't it? So prime source of heating of the water body is the solar energy or the sun. And the process of heating and cooling of oceanic water is generally slower as compared to the land. Oftentimes, as we have also seen in the case of Indian Ocean Dipole, the heating and the cooling of the landmass can also influence the heating and the cooling of the nearby water body as well. Oftentimes, that is the case. But here you would observe in general that, and this is where the temperature, the thermal image tells you a lot of things. Basically, you would observe that generally around equator, the temperature is the highest. As you move towards the poles, the temperature becomes colder. So latitudinal variation is a significant portion in contributing to temperature variation. So when we talk about the variation of temperature across the water body, that variation of temperature can be studied under two headings. You can have vertical variation, as well as the horizontal variation. That is, how is it that as we move from one area of the ocean to another area, let's suppose from here to here, why is it and how is it that the temperature changes? What are the factors included? So first we will study the horizontal variation of temperature. Then we will come across what is referred to as the vertical variation in temperature as we move across a depth. How is it that the temperature tends to vary? Okay, so you have various factors in place, but I think we should start it tomorrow, right? Right now, I want to give you certain areas for map pointing. Okay, so take this portion for map pointing, observe it in the atlas or in the Google map, wherever possible, look at it. So map pointing. First of all, trenches. Few of the trenches I have already given you. So in case you have already marked it out, fair enough. You have the Coral Trench, then Sunda Trench, then Mariana Trench. Tomorrow we have a class, my dear friends. Mariana Trench, then Peru-Chile Trench, then Japan Trench, okay? You even have a trench around Andaman Islands, but we'll come to it in Indian geography. Then straits and isthmus as well. Strait of Gibraltar. Where is it? Between Mediterranean and Atlantic. Then Strait of Malacca. Okay. Then after that, you have the strait around Dardanelles and around Black Sea also. You have a couple of straits. Look at those as well. Then Isthmus of Panama. Isthmus of Suez. Isthmus of Kra. Okay, look at all these as well. Then after that, Gulf and Bay. Gulf of Mexico. North Sea, then Sea of Marmara, Azov Sea. Okay, look at these areas, and then in fact I should give you more. So also look at Great Barrier Reef, where it is here. Also in the case of Strait, look at Cook Strait. Here look at Tasman Sea, and Ross Sea you have already located. Okay, so locate these areas and then come to the session tomorrow. Tomorrow we will be looking into the depth of oceanography, and we'll also try to study the portions of coral reefs. Okay, yes, Bay of Biscay is another one. Why Arabian Sea is a sea and Bay of Bengal is a bay? What is a bay? Bay and gulfs are those areas where the water is supposed to come inland in the case of water having a kind of an indenture or land mass having a kind of an intrusion. So that is where you have bays and gulfs. If the opening is narrow, it is referred to as a gulf. If the opening is wide, it is referred to as a bay. Arabian Sea is a sea because it is much larger as compared to the Bay of Bengal. It is much, much larger. It has much wider opening. So that is why it cannot be categorized under the portion of bay. Bays are much smaller than the seas in general. Okay. Then Karthi once explained deep sea plains and oceanic deep. Deep sea plains are like flat featureless plains that you find at the sea bottom. These are very much a part of the oceanic crust. And here, obviously, at that great depth of 4 to 6 kilometers, you don't have the availability of sunlight. So that is why this is an area under permanent darkness. And when we say oceanic deeps or the oceanic trenches, these are the ones where under geomorphology you would have studied that you have the whenever continental crust converges or continental or rather oceanic crust converges or an oceanic continental crust converges, there's a deformation leading to formation of a trench. In case you have missed out geomorphology, kindly look back at the recorded videos of module 2 and 3. You'll get a significant idea about it. Rakibul gulfs are again those narrow water bodies where water comes inland, but it is much narrower as compared to a bay. Okay. Sachin, why the rockets are always launched from Andhra Pradesh? That is where you have a large launch station. Generally, we had talked in module 1 that almost all the rocket launches which are there, the effort is to have it closest to the region of equator. That is why another launch station is being constructed in the region of Kerala. That will take us much closer to the region of equator. Okay. Amit, continental shelf is similar to the beaches side. So think about it as extension of the beaches that you have, Amit. Pranay, I observed that in Arctic Ocean, connected with many marginal seas, contain continental shelf countries. Yes. So around that region, their geopolitics and geostrategy is at its level best because Arctic is a region which is rich in oil reserves. So almost all the countries have their attention pinned to that. Vipin, a river carries a lot of sediments along with them, and these sediments may act via turbidity action? Absolutely, yes. Absolutely, very good. Then we have Himanshi. The warm and dry wind suddenly increases the temperature in temperate grassland due to the Chinook. only in certain cases. See, where the Chinook blows, only in certain patches you have those temperate grasslands. Generally, the temperate grasslands are found in the areas where you have the tornado formation in the plain region of United States. So that is a central portion. Okay. And right, so most of the questions I have taken. Okay. Right. Mupkalvar, can we say that canyons are the best place to generate tide energy due to turbidity current? Yes. See, but when we say tide energy, oftentimes it is the vertical variation, but also temperature plays a certain part. If there's a temperature variation, that can also help. But yes, very good. Beautiful. Okay. So just like that, keep applying yourself, keep revising. It is very, very heartening to see the level that many of you guys have attained. Very good. Just continue this. And paper one will be an easy walkthrough for many of you, at least the portion of geography, along with the portion of current affairs. So, okay, last question, Amit. The China Gulf type, natal type climates, these are the moderate type climates, China type climate, and is the one where you receive rainfall during the summer months because the ITCZ shifts there. That is why you have the rainfall in that region. Winters are dry because that region then starts generating offshore winds. And then Gulf type around the region of Gulf of Mexico, coastal areas receive rainfall throughout the year due to instability in air. And natal type, there also in the coastal areas, many of the regions receive rainfall throughout the year. Biswajit, as I told you, you need to work a bit harder. Look into the portion of English language. See, if you have made up your mind that you will appear for the examination in English language, there is no other process than to improve your English, rather than relying on those particular sources which will make it easy for you. For example, let's suppose if I am the one who will be conversing in Odia and Hindi, I'm sure many of you, especially in those portions, you will find it very easy to follow. But that is not going to help you in the long run. So put yourself in the danger zone, start conversing in English, start reading as much English as you want, as much as you can, listening to English. That is when the subject, or rather the entire language, will come to you. It is a process which takes time, but once it happens, it is very rewarding. So with that, we end the session today. We meet again tomorrow, where we will study about thermohaline circulations, oceanic circulations, and also the corals. Till that point of time, take care of yourself. Goodbye, and thank you.